Good morning everyone. Welcome to the lecture series of antenna and wave propagation. This is the introductory lecture. My name is Mareddy Anusha, Assistant Professor in the Department of Electronics and Communication Engineering, B.V. Raju Institute of Technology, Narsapur. So before going into whatever the contents or chapters are there in this antennas and wave propagation, first of all, what is an antenna? So nowadays in real life we can see these antennas in different shapes or different type of structures. Let us say nowadays in homes we can see these type of antennas like Wi-Fi routers, and we can see the television. We are using the antennas for the purpose of television or satellite communication. Then what is this antenna? So an antenna is a transducer, or it can be, we can call it as an aerial. So the antenna is a transducer. In general form of the transducer, so the transducer will convert one form of energy into the another form. So here the antenna also doing the same thing, but here the antenna which converts the electrical power into electromagnetic waves, and vice versa. For that only we can say that antenna can be a transmitting purpose or it can be used as a receiving purpose. So from this one we can say that antenna is a transducer which will convert the electrical power into electromagnetic waves and vice versa. So that antenna can be a transmitting antenna or it can be a receiving antenna. So that like whatever I said, that it is everywhere, like in mobile phone to transmit or receive the signals, and in laptops, Wi-Fi routers, mobile towers, satellites, like that, these antennas can be used in everywhere nowadays. So this is antenna. Then why to learn about the antenna? Then what is the purpose of antenna? This is the definition of this antenna. So nowadays we can see, or these antennas can be different shapes for different type of applications. Let us say the basic antenna is the wire antenna. This is the shape of the wire antenna. The next type of antenna is a lens antenna. The next one is array type of antennas. So here more than one antenna can be made as an antenna to improve the directivity and gain of that particular application. The another type of antenna is aperture antennas. So one example for this aperture antenna is like a horn antenna, and this is used for the high gain purpose. And the next one is a reflector antennas. Nowadays we are using this dish TV antennas. These are that is one type of reflector antennas. The next one is a microstrip antenna, and this antenna size is very less, so we can insert these type of strip antennas can be anywhere, like it is a shape of patch. So these are the some types of antennas. And so in this antenna and wave propagation course, so the basic main in under this antenna and wave propagation course, let us say this entire course will be divided into 5 chapters. So in this one, the first unit is deals with the unit 1 is related with the antenna fundamentals and radiation. First, what is the terminologies associated this antenna, and what are the basic parameters or fundamentals of that antenna. So here we have in this one, let us divide this chapter into 2 parts. The first part is deals with the fundamental basic parameters of the antennas. The second part is if the signals are coming out from the antenna or receiving by the antenna. So here we are representing that with the EM waves. Simply we can say that radiation. So what is that radiation mechanism? How it is going to transmit or how it is going to receiving? That all were there in the radiation mechanism part. Then coming to the basic parameters or fundamental parameters of the antenna. So here we have different types of parameters dealing with this, associated with these antennas. The first parameter is gain, directivity, effective aperture, bandwidth or beam width, and antenna radiation efficiency, input impedance, antenna noise temperature. Along with this, some more fundamental parameters are there for the antenna associated with the antenna. And the next two, coming to the second part, that is a radiation mechanism. So here how let us say if in this one let us consider one example like in linear wire antennas. So in this chapter, the completely it purely deals with the linear wire antennas. So depends on the length of this wire. So thus antennas will be divided into different types. let us say it as a short dipole. Let us say if the length of the wire is exactly half of the wavelength, then it can be called as half wave dipole. If we, by using that wire, if we made it as a loop, then it can be called as a loop antennas. So how the radiation is associated with these type of antennas, that entire concepts were deals in this linear wire antenna. This is all about the chapter 1 in the antennas and wave propagation. Then coming to the second chapter, so the second chapter is antenna arrays and antenna measurements. So in this unit, if so in the first chapter we were discussed about just about the thin wire antenna. By using that single wire, if we use more than one antennas in the structure, we made it as a structure of antennas, then it can be called as antenna arrays. So this antenna arrays depends on the spacing between the elements, or depends on the whatever the elements or antennas used in the array structure. So we are dividing that arrays into different types, and depends on the application also we are giving a different names for that antenna structure. Though if we are placing, if more than one antenna is there on that structure, so again then how to calculate the radiation from those array of antennas, that all can be dealt in antenna arrays. Then the second part, then coming to in this second chapter, that is antenna measurement. From that, if we made array structure, or else if we constructed one antenna type, so how the whatever we were discussed in the first chapter, the parameters like impedance, gain, directivity, how we are going to measure those parameters. Those all concepts were explained in this antenna measurement chapter. So for that, it is a directivity measurement, gain measurement, and pattern measurement. In this way, we are going to deal with here some impedance measurement. This is about the second chapter. Then coming to the third unit. So here in this chapter, so these whatever the antennas, here we are going to discuss about the different types of antennas, constructions or structure, and application of those antennas. So these all antennas were worked under either in VHF region, or else ultra high frequency regions, or else in microwave antennas. So in this one, the examples are Aggie-Wood array, and this is Aggie-Wood antenna and helical antenna. The next one is horn antenna, reflectors, that is a paraboloid reflector, and the next one is lens antennas. So these lens antennas can be operated under micro frequency region. So this chapter is having, this third chapter is having about these all antenna structures and construction of these antennas. Next one. Then coming to the fourth chapter, so the same way in the third chapter we are going to discuss about the some antenna structure, as well as some more antennas were explained in this fourth chapter. The same different types of antennas like microstrip antenna and rectangular patch antenna, and the modern antennas nowadays, these fractal and dielectric resonant antennas used for the most of the medical applications. If we want to insert these in a small, make it like a small size, or if you want to increase more directivity or gain of this patch antennas, so nowadays they all are using this fractal antennas as well as the dielectric resonating antennas. Then coming to the fifth unit, so this is this part up to first, second, third and fourth, this completely associated in the word with the antennas. In the subject we have antenna and wave propagation. This fourth chapter is associated with the antenna word. Then coming to the fifth unit, this was related to the wave propagation concept. So after constructing, designing different types of antennas, whatever we are going to discuss in the third and fourth unit, so if that particular antennas are radiated, propagated waves into free space. Now, so what happens on that free space? How the wave is going to propagate on that one? So depends on the atmospheric structure. That atmospheric structure will be divided into three types of layers. One is, we can say that ground wave, that is very near to the earth. The next we can say that sky wave and space wave. So this wave propagation concept will be divided into two parts. So under this wave propagation one, so what is the propagation? What is the concept of wave propagation? And what are the different modes of propagation? So depends on the atmospheric structures. So these layers will be divided into different types. If the wave enters into one region, how it is going to be propagated, that particular mode of propagation we are going to discuss. So and that one, let us say one is a ground wave propagation, the next one is space wave propagation. In this way we have one more layer in the atmospheric structure, that is a sky wave propagation. If the wave is enter into the sky wave region, so how the wave is going to be propagated. So then under this sky wave propagation, we are going to discuss about the structure of ionosphere, and here some terms are associated with this sky wave propagation. Let us say it as a critical frequency, virtual height, that is maximum usable frequency MUF, as well as skip distance. So these are all the contents were there in this course antennas and wave propagation. So to get, or after completion of this course, if before to understand this course, the student should have the basic knowledge about the electromagnetic fields and waves. If they have a basic knowledge on this electromagnetic fields and waves, along with that they should have the basic knowledge on some integration and differentiation, then only this course will be easy to understand and it will be easy to analyze also. When we are dealing with some field analysis part, they should know the basic integration as well as differentiation equations. And then we can say that the prerequisite for this subject is electromagnetic fields and waves. So thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.